11.2 areas of regular polygons. So what's going to end up happening is we're going to end up being able to take our polygons and divide them into triangles, okay? So the basic formula for area of a triangle you guys know, right? It's area equals 1/2 base times height. When you have an equilateral triangle, you don't need a base and a height, okay? You can just use the side of the triangle. So that's theorem 11.3. And it tells us that we know an equilateral triangle has congruent sides, okay? So the area of an equilateral triangle is going to be 1/4 times the square root of 3 times the length of a side squared. Okay? And then we're going to be able to use that to find area of other polygons. Okay? So if you have an equilateral triangle where sides are 10 centimeters, then the area is going to be 1/4 times the square root of 3 times 10 squared. Okay, order of operations, 10 squared is 100. Then we can multiply in any order. So it's going to be 100 times 1/4, which is 25. I am fine with leaving the square root of 3 in there. And it should be centimeters squared. I messed that up in your notes, okay? Because it's area. So there's no need to multiply this by the square root of 3. It's going to give you a decimal. This is the exact answer for the area in radical form, and it's perfectly acceptable. Okay? So if you know a side, you just square it, multiply it by 1/4, and then multiply that by the square root of 3. Okay? All right, that's only equilateral triangles if they all have the same side length. Okay? All right, so we want to prove that an isosceles triangle with base B and base angles that measure 45 degrees is going to have an area that equals 1/4 the square of the base. So 1/4 base squared. Okay, so isosceles trapezoid means two sides are congruent, okay? And then, so we're going to call this triangle PQR. And here is our base, okay? And then base angles of 45. This is 45 degrees. Okay, then we know that the area of any triangle is 1/2 base times height. Okay. So we want to show that this is equal to 1/4 times the base squared. So we are going to draw in an altitude, right? So altitude is perpendicular to the base. And we're going to call that PS. So that ends up being our height, okay? Because this was a 45, 45, 90 triangle, we knew that this was also going to be a 90-degree angle. So we just divided it. So this is also 45 here. And it's congruent here, okay? All right. So that tells us that QS, which is the height, and PS are going to be the same, and SR. Okay, so QS, PS, and SR are now going to be congruent. Okay, because it's a 45, 45, 90 right angle. So the sides opposite the 45-degree angle are congruent. Okay, so since we look here and we know that the base is going to be PS plus SR, okay? QS is the height, right? We can say then that the base is twice the length of QS, which is twice the height, okay? Because QS is the height. So then the height is, so if we know that the base then is twice the height is half the base, or base divided by 2, okay? Well then, plugging this into area, we get area equals 1/2 times the base over 2, right? Well then, 1/2 times base over 2 is 1/4 times the base squared, which is what we wanted to show for this isosceles triangle. Okay. Now, we are going to look at other polygons. Okay. Consider a hexagon, right? Hexagon is 6 sides. And we're going to consider a regular hexagon inscribed in a circle. Okay, so 6 sides. We're going to say all those sides are the same, and we're going to inscribe it in a circle. Okay, so that means that the vertices are all on the circle. We've got the center of our circle here, happens to be the center of the hexagon as well, or the regular polygon that's inside the circle. Call it G. Okay, then we're going to just label. So A, our vertices, B, C, D, E, and F. Okay, so just like the angles, we can take our regular polygons and divide them into equilateral triangles to find the area. Okay, so if I make one equilateral triangle like this, okay, we're going to draw in its altitude and we're going to label this point H. Okay, the center of the polygon is the center of the circle, and the radius of the polygon is the same as the radius of the circle. Okay, so this is the radius of the circle, radius of the polygon. The distance from the center to any side of the polygon is called the apothem. So this height here that we drew in, so we're going to call GH the apothem, or lowercase a. This is center to a side. Okay. So the apothem is the height of a triangle between the center of 2 consecutive vertices. So if I'm looking at triangle ABG, okay, the height is the apothem there. So I can divide this hexagon into 6 congruent triangles, right? 1, 2, 3, 4, 5, 6. Okay, so we can do that for any regular n-sided polygon. Okay, so then to find the area of it, we know that the area is going to be the number of triangles, okay, times the area. These are all congruent, so times the area of 1. Okay. Then we know that the number of sides is the same as the number of triangles, because we're going to draw one triangle for each side. Okay, then the area of a triangle is 1/2 base. So the base happens to be the side. So 1/2 times the side times the apothem, because the apothem is the height. Okay, so area is 1/2 times the apothem times the number of sides times a side length. So this also happens to be the perimeter. So we can say it's the 1/2 times the apothem times the number of sides times the side length of a side. Or we can say it's 1/2 times the apothem times the perimeter of the rectangle or the polygon. And this is actually theorem 11.4. Okay, so the big key is being able to find the height and the side length, okay, because the number of sides you just count. So we need to know the side of the polygon and the apothem, okay? So how are we going to do that? Well, that comes into play with the angle here. So what you're going to need is you're going to need your central angle. The central angle is this one here, okay, at the top of the polygon, or at the top of the triangle, opposite the side of the polygon, okay? The central angle has a vertex at the center, and the sides are connect the center to two consecutive vertices. Okay, so to find the measure of the central angle, it's going to be 360, because that's if I went all the way around the circle, divided by the number of sides. Okay, so then that ends up giving you this triangle, right? If I just take out this triangle, we're going to say this is G, A, and B. This is the central angle. Okay. Then you draw in the height, and it bisects the central angle. Okay, then you use your trig ratios, because you're going to be able to have this angle up top, and then you're going to know like the radius, or you're going to know this side. This is also half the full side. Okay. All right, so let's see how we do this with numbers. All right, you have a regular octagon inscribed in a circle that has a radius of 4. Okay, so an octagon is 8 sides. Inscribed in a circle. So here is our circle right along, whoops, the octagon. Okay, here is the center. I'm going to just label it B for now. Okay, so I want one triangle. We want to find the area of it. We know it's going to be 1/2 the apothem times the perimeter, or 1/2 the apothem times the number of sides times a side length. Okay, we're going to call this A and C. Okay, we said the radius was 4, so we know that AB and BC are 4 units. Okay, then we're going to look at this triangle here. So I'm going to draw it. Here is B, A, and C. We know these are 4. Okay, then you're going to find your central angle, which is going to give us this. So angle ABC is going to be 360 divided by 8 because we know they have 4 sides, or they have 8 sides. Okay, so that's going to be 45. So this angle here is 45 degrees. But I need to break it down to even a smaller triangle because I need the height. So I'm going to draw in the height here. Okay. Which is the apothem. Okay. So we end up bisecting 45 degrees. So we're going to label this D now, and we're going to say that the measure of angle ABD is half of the central angle, so half of 45. Okay, now we have this triangle here. So here's a right angle. Here is A, B, and D. Okay, this is our apothem. This is 4, and this angle is 22.5 degrees. So we need to know the side, and we need to know the apothem. Okay? So 4 is the hypotenuse. So we're using the side adjacent over the hypotenuse, which is cosine. So the cosine of 22.5 is the side adjacent over the hypotenuse. So the apothem is 4 times the cosine of 22.5. We're going to leave it like that for now. No decimals until the very end. Okay? Then we know AD is half the side of our triangle. Okay? So that's the side opposite the angle. So the sine of 22.5 is the side opposite, which is half our side length over the hypotenuse. So let's label it AD for now. AD is 4 times the sine of 22.5. Okay, that's only half of our side, so our side length is twice this. So our side is going to be 8 times the sine of 22.5. Okay, then we have our side, our apothem, and the number of sides. We can find the area. So the area is 1/2 times the apothem times the number of sides, which is 8, times a side length, which is 8, times the sine of 22.5. Okay, and then multiplying this out, we get the area is 45.28 square units. Okay, so there are a lot of steps to finding this value. Okay, what you need to do is you're going to break it into a triangle. Then find the central angle. Okay, then draw in your height, divide the central angle by 2, label what you know, whether it's the apothem, whether it's the side. Once you draw in the height, the side gets divided by 2. So if you know a side, half of it will give you this piece of the smallest triangle you can find. Okay, then use your trig ratios to find the other measurements, and then plug it all in to find the height.